Right, welcome. I hope everybody enjoyed their lunch and that the last people are finding seats. Otherwise, fill in the gaps so everybody can be here. There's more people than expected. That's good, I guess. Well, the title of the talk is Effective Testing in Microservice Systems, but I guess you already know that because you're here and you can read and everything. But anyway, that is the title of the talk. My name is Christian. I wrote this Microservices book, and much of what I'll talk about today is in here, not all of it, but much of that is, and there's a lot of content surrounding the topic that I'm talking about today in here as well. I brought 2 copies, so the first people who ask for them after the talk will get those, if you want them. That's not the point. The point is the talk. So, it was effective testing in microservice systems. So the first question here that pops up is, what should we test? And, well, it sounds like a very concrete question, I guess it is, but the answer might not be quite as concrete, but we'll slowly get into that as we move through the talk. But really, I think it's very much about testing enough to have confidence to deploy to production. And that means different things for different systems. There are different consequences to different systems getting it wrong in production, so there's different tolerance of risk. But you need but overall, no matter what the tolerance of risk is, you need the confidence to actually deploy to production, otherwise you're just stuck in your test environment. That's no good. So that's something we want. We also want the maintenance effort to be sensical. So you can't spend all your time writing tests or doing manual tests for that matter. You probably can't spend 0 time either. That probably wouldn't give you the confidence to deploy. And then, well, this is not really a what to test, but it's a why is testing a separate topic when we talk about microservices, is that you quickly, when you move into microservices, get hundreds of services. Well, maybe not quickly. Actually, I think in my experience, it looks like people spend like 6 months building the first microservice, and then they spend 6 months building 5 more, and then it accelerates. And 6 months after that, they have 100, and then it just goes up from there. So they really accelerate. And you probably need to get on top of your testing strategy before you have 300 services in production, right? Because if you have that many, you sort of can't really just sort of bring it up all locally and just test out everything and all combinations of everything. That's not really an option with that many moving parts and that many services. So we sort of have to attack it slightly differently than that, and that's what we will get into. But first, we need to detour a little bit and just very quickly talk a little bit about what a microservice is in my world, at least. I think you can find lots of different definitions. So what I'm going by is that a microservice is something that is responsible for a single capability. It's individually deployable, so you can deploy one without deploying the whole world and all of it, so that testing enough to have confidence to deploy, that's about, well, you deploy one at a time. So you have to have the confidence that you can actually do that you don't have to orchestrate all of it all at once. Yeah, so there can be more than one deployable unit. That's not really that important in this context. There's a data store associated with each and every one of them that has some impact on the testing strategy. And well, in terms of size, a small team can handle, well, actually a few handfuls of services, and this is like really gray area what that actually means, but I think it gives a feel for the kind of size that we're looking at and the kind of things that we're looking at. And they are replaceable in the sense that since they are so focused, it's actually possible to say, oh, that was the wrong technology, we're going to implement it in something else and do that in the normal pace of work without sort of spending the big replacement project that never ends. So that's also something that you sort of have to probably take into consideration with testing, that you need to support this tenet as well. Okay, so making it a bit more concrete and having a bit of example of what a microservice might do, because I think that impacts the testing effort quite a lot. We can think about a loyalty program. So whatever chain of stores you might be able to think about. You can have like an app or a plastic card, and then every time you buy something, you get loyalty points, and then they try to make you buy even more or stuff like that. Many companies have these. You probably know about them, right? So you could have this loyalty program, the green one in the middle, and it has some connections to some other microservices. And the exact connections here are not that important. The ones that we're concentrating on today is in the upper left-hand corner. There's the up there. Sorry, there. There's the special offers microservice. So you could imagine that there's a back office UI something where somebody can put in a special offer and say, on Saturday you can get 3 for the price of 2. Then the loyalty program picks that up as an event, says, okay, who's interested in that? And everybody in the loyalty program who we think are interested in that, we give them a notification, email, text, whatever, and say, okay, go buy our fabulous stuff because this is something you usually buy. So this is sort of an approximation, that loyalty program. That's the first approximation of how we might break a small part of this system into some microservices. So this is trying to make it a bit more concrete what we're talking about. And why exactly that? Well, because the scope of a microservice should really be driven by business capabilities. So a microservice should be responsible for a single business capability. And this is important in terms of testing, because that means that now we're talking about something that we can talk about how it should work with, that isn't technical, it's actually business, and that's what we want to test. We want to test that capability. Now, what does a capability mean? That's a little bit difficult, and that's why I said that the loyalty program is kind of the first approximation, because if you drive into it, it tends to be that there's more things inside of what you might at first think is a good capability. So if you do some, I don't know, brainstorming, event storming, you do some of these different ideation techniques, or just really go talk to the business, or the business tech is hopefully part of the business. Go talk to other parts of the business. We'll probably usually find out that there are more details to things. So off the top of my head, a loyalty program, there's something about issuing and canceling these plastic cards. There's something about awarding these loyalty points. You might decide that everybody with lots of points, we organize a monthly raffle and they can win something. Or they might be eligible to these special offers based on their points and their interest and stuff like that. Or you might even organize special events, like the car dealership that loves you will invite you for golf because then they hope you buy an extra car or something. Could be smaller things as well. But there could be different things, right? So it could probably turn out that loyalty program might over time not actually be a service, but it's a bounded context, which is a term taken from domain-driven design, which is sort of a grouping of these services that kind of belong together and form a cohesive all. And then some of these that we have had on the previous slide might actually be the capabilities that we have in different services. So my point in showing this, even though we're actually talking about testing, is that it sort of turns out that a microservice system evolves over time, as does any system. And what you'll see is that you'll have different areas of the system that look different in terms of the breakdown and the size. And we can use that to guide some of our testing efforts as well. So when we drive into what something really means and how it should really work, and we want to experiment with it and we want to develop it and it's important for the business, it tends to get broken more down. So that might be the green one over there that has smaller services inside of it because we've worked in more detail with it. Then the red one at the bottom, well, there might be something more emergent that we're not that certain about yet. So we have a slightly bigger service and then sort of some smaller ones beside it because we're not quite sure yet how to chop this up in a really good way. And we're not maybe sure of the importance yet either. And then the blue one might be just something that we just buy from a third party because it's just generic for us. So again, in DDD terms, this might be the core domain, and this might be a supporting subdomain, and this might be like a generic third-party thing, a generic subdomain. And already here, we can sort of think about, okay, where do we really want to concentrate the test efforts? We probably want it around the core, and secondarily around the supporting subdomain. Of course, we want to test everything and want to be really good around everything, but we don't live in a perfect world. So maybe sometimes we actually do have to prioritize just a little bit. And I think concentrating on the core is probably a good idea when it comes to testing as well. So, okay, so now let's get into tests. And we'll just start off with the with this. The test pyramid, I'm sure you've seen it before. It's been around for a long time, quite classic. We have unit tests at the bottom. Then we have a middle layer, and on top we have, and then the top layer we have system tests. And in the middle one on these slides, I've written service tests, and that's not usually what it says there. It usually says something like integration tests. That's probably often what you would have seen. But when it comes to testing microservices, I think it makes more sense, at least when you sort of get over the hump of seeing it a little bit differently, to talk about service tests, because a service test is, well, something that tests a microservice. And if we look at this picture again, we can see, at least in the core, those are some quite small ones. And yeah, there might be some integration anyway going on, but it's kind of a nice testable unit. So I think I've already said that's the one thing you should remember from the talk, that one microservice is actually a quite nice testable unit. System level tests, those are, I don't think they are that different when we talk about a microservice system compared to a monolithic system or a more traditional SOA system where we have bigger services. They are black box, so they don't know how things are implemented. So it really shouldn't be that different based on what they are, how it's implemented. They test the complete system, and my recommendation is usually that those should cover the most important happy path use cases. Not all use cases, because that tends to be too much maintenance effort. But again, what are the most important? That depends on the how risk averse we are in a given situation compared to, well, the consequences and so on. But as I said, I don't think the effort putting into system level tests is so different because it's microservices. So I'm not going to talk more about those. That doesn't mean I don't think they have a role to play. I do. It's just not different based on whether it's a monolith or it's microservices. The service level tests, the middle level, I think are very different when it comes to a microservice system. So we can test a complete microservice, and I think that's what we should do at this level. We can have the other services be stopped or marked, depending on which word you prefer. Just meaning that we'll have fake versions of the other microservices. And I sometimes think about these as sort of a gray box. So we have the black box, white box terminology, and this is sort of gray and in between because it's from the outside of the microservice. We test the whole microservice. So if the microservice were a system, it was an end-to-end complete service system test, but it's not. There's there's dependencies and collaboration between these different microservices, and since we are mocking the other microservices, we do know something about the implementation. Not inside of the microservice, but in part of the system. So it's kind of a gray in-between thing here. And I think with this level, we can cover all the important scenarios for that service, meaning all the important scenarios for that business capability. So that comes back to why I wanted to point out that the scope and responsibility of a microservice should really be a business capability, because this is something that we can put on a slightly higher level of abstraction than the technology and the implementation, when I actually talk about what's important in terms of, say, a loyalty program. Which scenarios should it really always support? And as opposed to system, where I tend to mostly go for the positive heavy path things, this can easily be. This also can include negative things, failures of different kinds. Right. So another thing that we could notice from that. I'll just jump back to it from. There we go. From this picture is that there's a lot of arrows between these things. Now, depending on what those arrows mean, we can have a higher or lower coupling. So even though there are a lot of arrows, we can have nice low coupling. But it does mean that there is collaboration going on between these microservices, and it does mean that if we just take one of the white boxes and isolate, then we can know a lot about how well that one works. But what does it tell about the system? Well, it tells us something, but we don't really know about the arrows. So I think that's another thing that happens when we move from either traditional SOA or monolith and towards microservices, is that we take some of the complexity that we already have in our code bases, and then we move it sort of outside of the code bases into the collaboration. So we move it from the code base and onto the network, be it queues or gRPC or HTTP APIs, no matter what. I mean, we're moving it from how the code works and to how the code communicates. But that doesn't mean the complexity is gone. We've just moved it. So we want to look at covering that as well. Let's just jump. So once we're here, where we were before, we've covered the service, but we haven't covered the arrows. And that's why we want to supplement this with contract tests, which exactly cover the arrows. So I think this, what we've summarized on this slide, I think is really the new thing when it comes to having good test automation around microservices compared to other architectures. Unit testing is the last part of the pyramid. Still important, but just like with system tests, not that much changes just because you move to microservices. You should test a unit of behavior. I'm pausing here because I think that's important and it continues to be misunderstood. So we're not testing a class. We're not testing a function. We're testing a unit of behavior. And it doesn't really matter if it takes two classes to implement that behavior. So you don't have to have exact same structure in the production code and the test code. It doesn't have to be one-to-one the same files all over, because then you'll really hamper your ability to refactor. So don't do that. Focus on behavior, please. And try to avoid mocks. Don't mock too much. You just end up fighting the mocking frameworks instead of delivering actual code. This might be the last thing I'm going to say about unit tests. There might be one more slide I can't exactly remember, but that's about it, because again, this isn't that different. So, on to these service level tests again. And let's look a little bit more at it. So back to the example as well with the loyalty program, and we're now back to the state where we haven't done the further breakdown of the loyalty program. We just see it as one loyalty program. The company has decided we need a loyalty program. So for now it's one thing, and then we might discover that it's more than one thing as we go. So, well, demo is maybe overstating it, but I'm going to show you a little bit outside of the slides. So we have a loyalty program running. It has some HTTP endpoints. It's not that it's not that advanced really. There's a post endpoint to register users, and that's, where's my mouse? Which we can open there, and then when we register somebody, we can sort of register a few interests. So they might be interested in basketball and I don't know, children's books or something like that for some reason. Then we have another service running. We have the special offers one. It's really doesn't do that much, and it has this fantastic UI that I know every business person would love, that allows them to create a special offer, and they can't really do that much. They can describe the special offer, and then they can put some tags on, and those tags will match against the interests of people in the loyalty program. So if they make a special offer for children's books, then the person talked about before might get a notification saying, hey, we have a good offer for children's books. When something is posted into this endpoint, what the special offers service does is that it places something onto a queue. I've just used RabbitMQ here. It's not about which technology. It's just some queuing system that says, hey, there's a new special offer. So special offer created. And then we have, back actually. There we go, the loyalty program. Sorry for all the switching. Back to the loyalty program. So this one will listen on that RabbitMQ queue and get the special offer, match it against the interests of whoever's registered. And then lastly, the loyalty program will call this post endpoint on the notification service, and then it's the responsibility of this service to actually notify people via however they want to be notified, whether they prefer email or text message or whatever. Okay, so I'm not going to go through posting into these because that's not really that interesting. And well, it works. Yeah. So back to the slides. So let's talk about if we had that system. So right now we sort of just have that system. We've thrown it into production, no tests at all. So that's not that good. That doesn't give us confidence the next time. So we want to get started writing these service level tests, and we should test the complete microservice and mock the other ones. So what we have is that we have the loyalty program, and that's the real code running like it really does, using the real database and real HTTP and real RabbitMQ and so on. And then we have a mocked special offers microservice, and we'll get a little bit back to what mocked even means. It sounds bigger than it is. It's really small, you will see. But what we need is something that sends an event over Rabbit, and we just send a canned event, just something hard-coded, because then we know how the loyalty program is supposed to react, right? And then the loyalty program sends a command over to a mocked version of the notifications microservice. And a command here really means it calls that post endpoint that the notifications service had. And then the mock that we have will just give a canned response back. He'll just say, okay, that's fine. And that's what we'll do for now. And of course, you can do lots more. You could have error scenarios. Maybe it's down, or maybe it can't find the user it's supposed to notify, and so on. You can test these scenarios out as well. And the way we can set it up that I find is quite nice is, again, run the loyalty program for real, the real code, the real everything. And then we have, beside that, we have well, it says integration test. I'm sorry about that. It should say service level test process. So I can't even switch from integration to that. So we have a service level test scenario running in there, and what that does, and that's kind of the mock of the special offers, is it just puts a message onto that RabbitMQ, which is kind of nothing special. That's also what we do in our real code. So just do the things that we already know how to do over in the tests. The real code turns around and makes a request to the mocked notifications microservice, which we are actually running inside of the same process, because it turns out that we know how to take processes and host HTTP endpoints, because that's what we do in our real code, so we can also do it in our test code. So we're just doing the things we already know how to do. And then this is really, really simple endpoint. It'll just say OK and record the fact that it was called and how it was called. Yeah, so a little bit of demo time. That looks horrible. Let's see if that looks better if we just go out of presentation mode and back into it. Enter presentation mode. Okay, so that's a little bit better. So we have a test here, and that's our scenario. And the scenario is that we want to notify an eligible user. That's been the thing all along. And we just, we can refactor code. Again, that's exactly like we do it in the production code anyway. So we can, of course, split things out into methods, so we get something that looks like the capability, like talking about the capability, the business capability of the service. If we register a new user and create a special offer, we want to assert that the notification was sent. Okay, so that's a capability that we want the loyalty program to have. That's one of the things it should do. So, again, without using a lot of special frameworks or anything, we are able to write a test that kind of talks in that language. I'm not saying you can just turn around and show this to your business people and have them write it, but at least you can have a conversation about what this actually really means. Because if they can just ignore like the parentheses and the await and stuff, then register a new user, create a special offer, and a notification was sent. Okay, we can talk about that. So how are these implemented? We have the register user just above here, if I remember correctly. Yeah, there we have it. And this is, of course, more technical and not very business friendly. But this gets a little bit closer to the implementation. And this is where sort of it gets gray box, because we don't know exactly what's going on inside the loyalty program, but we do know how to talk to the loyalty program sort of technically. And what we do is that we take an HTTP client, this is an HTTP client, and we post something to it, and we post to the /users with whatever body we need in order to actually create a user. So blah, blah, blah. This calls an endpoint and registers a user. We do the similar kind of thing for this create special offer. We have this below, down here. And here we go. So we create an event. And we probably already have this type that defines the event, because we need it over in the special offers. So this is not something that we're making up for the test. It's something we already have. And we probably already know how to talk to RabbitMQ, because the special offers microservice does that. And that's what we're doing here. So again, we're publishing something onto RabbitMQ. And then we wait for a while, because now we've registered the user, created a special offer, and then the assertion comes, and then there's this exponential retry policy here, where it's in order to make these kinds of tests run is necessary. I'm using the poly framework here. Sort of show of hands, does people know poly? Okay, so I'll not talk a lot about poly, because I think 80% put their hand up. So we're using poly in order to do some retries and wait, which is sort of a fast way of waiting. And when it works, this will just run through really, really fast. And then when it fails, it's slower because we have to wait for the retries and the timeouts and stuff. But I don't know, I'm an optimistic person, so I tend to like that it's fast when it works because it probably does most of the time. So there we go. So that's one of these service level tests. And okay, just to go on a limb, let's try to actually run it and see what happens. And running. Oh, I know why. Oh, this is going to fail. Yeah, there we go. So yeah, and it failed slowly, as you noticed, because it had to time out and everything. The reason is that, okay, you can't really see what this is, but you'll have to believe me when I say that what we have running here in this terminal window is a copy of that loyalty program. So we actually have, like, we sort of had, I started one up in the test, but then I had a competing one already running, and that grabbed the message off of RabbitMQ, so it failed. So we saw a failure. Now I'll just stop that and take it off screen again. Back to the IDE and rerun, and then hope that I'm right. Yeah, you saw it run through, and it's much quicker when it actually worked. Yeah. Okay. So now we've established a test that tests the behavior of a full microservice. And of course, this was just a small one. But I mean, we can just keep going with these and actually cover scenarios that are important for that business capability. Now, the other part that I also wanted to test on this service level were the contracts. So the contracts between these different microservices. So here we were asserting that a notification was sent, but at least that's what we claimed we were asserting. But since we're only looking at the loyalty program, what we're actually asserting is that it made a request towards the notification service that, according to the loyalty program, is supposed to make the notifications send a notification. But there's some assumptions here, and there's the assumption that the notification service works and can actually send notifications. I'm okay with that at this level because I'm assuming that service also has tests. So I'm just looking at the loyalty program, but there's still the assumption that the way we're calling the notification service is correct, and that's the contract we're using. We also want to test that to have a good confidence. This is by no means a new idea. As always, Martin Fowler has written a really good explanation what this is more than 10 years ago. That's how it is with most things. I will talk a little bit about what it is anyway. So in the test that we just saw, we had the loyalty program send a command to the muck. The command is the post request. We did that in this manner where it sends a real HTTP request into the mock. Okay. So if we want to test the if we want to test whether that contract is the right one, we can sort of turn around and go from the mock, whatever the mock got into it is kind of the contract, or that's the expectation of the loyalty program. We can send that into the notification service, get a real response back, and then we can assert whether that meets whether that looks the same as the thing that the mock responds with. And if there's a discrepancy there, then the mock is wrong. And then we have to change the mock and see if the loyalty program now fails, and it might, of course. So that's really the basic idea of the contract test, record what we, based on the mock, what the expectations are, turn around and use that on the real service at the other end. Yeah, so putting that on a drawing, we still have the real HTTP request, and then once it gets into the mock, we can just record what happened. And recording, what does that mean? It means just dumping it into a file, really. So last look at code, and maybe we'll just actually close this and we'll be able to see something. Yes. And we will switch to another file. We'll switch to the notifications mock. So that's, to no surprise, the implementation of the mocked version of this notification service. And it's really not that advanced. And as I said, I mean, we're able to create endpoints in our services, so we're probably also able to do it here. Let's again sort of show of hands who has worked with ASP.NET. So this is familiar code, I think. A controller that can react to an HTTP post on some path, notifications, and it does something. It just says, yay, I got a notification request, and then it returns OK, so it says 200 OK. And that's the mocking part, and then the recording part is in here, and the details aren't that important. The important bit is write all text to a file, and the text that we write is the body of the incoming request. So whatever the loyalty program sends in, we write that down. And it just does it to somewhere called recorded contracts post dash notifications.json. So there's maybe also encoded a couple of assumptions here as well, that based on the name of the file, this is because it was a post request, and I'm expecting the body to be JSON here. Okay. So let's take a look at how that looks in. So we have those here, and just that's what on the last test run that we did before. This is the body that we sent, and this is the body that we wrote. Then we can turn around and create a notifications contract test here, and we'll have one that says verify loyalty program contract. And what it does is that, well, it has kind of an ugly path here, but it's a path to the JSON file we just looked at. And then it creates an HTTP client. Sorry, let's do it like this. Creates an HTTP client, reads from that file because that's the body of the request we want. It does the actual request towards the actual notifications. You can see localhost here. Depending on where and how you want to run your test, that can be localhost, or you could run it against the test environment. That's sort of also a consideration, but that depends a little bit on how your whole environment is set up. And then lastly, we have an assertion here that we have something to be, some expected status code that we want to get back from the actual notification service here, and that's a second argument that we have in this one. So we get that in as an argument. And it was OK in this case. And what we have above here, so this is XUnit. I'm using and assuming again that's probably, so again, show of hands, have you worked with XUnit? Yeah, have you worked with theories in XUnit? Okay, so that was less than half. So I'm going to explain what that is. So in XUnit, a test is called a fact. So we decorated with fact up here. And that's one example that you run as a unit test. Then a theory is kind of a collection of facts. And the way that you do that is that you take the test method that you already have, and then you parameterize that, in this case with a path to somewhere where we want to read that body from, and an expected HTTP status code that we want to get back. And then you could put in these inline data that says, okay, so the first argument I want to be this long string, that's the path, and the second argument I want to be HTTP status code OK. Then I could just have more of these. So if I had more contracts, I would just put them down here. And now my ID is telling me that I'm copying code. But if I did have more recordings, I could have those be one of these, because it's just exactly the same thing. And that's kind of a point. That's why, even though I just have one example, I used a parameterized test in the shape of a theory here, because it's really, I think you should really strive for making this test generic and then just fill in all those contracts. And that's in contrast to the other test we saw, that I don't want to be generic. I want that to be specific to the business capability and talk in business terms. This is much more technical. Just make it generic and test the contracts that you get out, because that's going to be the easiest way for you. Right. This was hand-holding the contract tests, which I think you can get far with. You can also look at some helpful tools. Mountebank is one. Pact is another. Pact is specifically for contract tests. Mountebank has a slightly different focus. Why didn't I just use Pact then? Well, because it doesn't do exactly what I've showed you here, but it does something useful as well. It's just more of a unit test style. It does for the recording, so it doesn't quite fit in with recording from these service level tests. But, I mean, that might be me being a little bit not invented by me, kind of, that I want it to be exactly my way. So do take a look at these as well. It might just be exactly what you need in your context. Right, so that's the whole thing for service level tests. There's the behavioral part and there's the contracts part. Below were the unit tests, and, well, as I already said, it's business as usual. Then we need to prioritize what to test. And we've talked some about this. Do the happy path scenarios, important happy path scenarios at the system level, goes across everything. Take a lot more scenarios, both positive and negatives, ones on the level of the services. And then the whatever details you have left, do that with unit testing. That's sort of my rules of thumb. And the way to make that actually happen, to me at least, is using outside-in TDD. So there's two parts to this. The first is TDD, which I am sure you also heard other people talk about from stages like this one. But it's going around in the circle of writing a test that fails, write the production code you need to make it succeed, and then refactor your code into something you can actually maintain, going around that circle, That's often talked about in the context of unit tests, but it works on other levels as well. There's no reason it only has to be unit tests. So with the outside-in approach to this, we want to write the high-level ones first. And I find that the really effective way to do this with microservices is to do it exactly at that service level. It's difficult to start at the system level, but if we do it at the service level, that's doable, and we can get some tests that we can get working. We can drive until that hurts. And again, there's gray area here. What exactly does that mean? It's one of those things. It takes some experience, and we kind of know it when we get there. There's usually some setup before we can have those nice scenarios that says register a new user, create special offer, assert that the right thing happened. And it kind of, then sort of that's okay. But if you need to get into something very, very specialized, there might be more sort of, okay, you have to, if you've registered exactly 101 users with exactly these permutations of interests or whatever, and then you post this special offer, then something. And that becomes more difficult. And then sometimes it kind of feels like, I mean, if there's a light switch on the other side of the stage, and you're just standing over here, and then you have a little stick, and you're trying to, there's the light switch. Then that's kind of hurtful. Then just then don't write at the high level. Switch gears and write a unit test that you can actually push the light switch. So you shift down when it becomes too difficult. And yes, that's gray area, and yes, that takes some experience to do. And then you just repeat. And again, everything has been written a long time ago. Well, long in tech terms. So this book, Growing Object-Oriented Software, Guided by Tests, that's probably more than 10 years old, I'd guess. I should have looked that up beforehand, I didn't. Really good book, and describes this in detail. And it says object-oriented. I think if you want to be more functional, because that's more hip today, the ideas still apply perfectly. And then you can start from that service level of tests and drive your way into a good test coverage and get the unit test that you need. And then you might not get exactly the pyramid shape. You might sort of get going out and then just fewer unit tests than the pyramid sort of indicates. But that's okay as long as you actually get the confidence to deploy as often as you need, which is often with microservices. All right, so another level of prioritization was around which areas of the whole thing should we concentrate on. And I think we can use some of the things that we can grab from domain-driven design again, where we prioritize where to put in the engineering effort and the whole effort in general, not just engineering, and also let that apply to our testing effort. So there's this thing called a core domain chart, and if you were in this room before lunch, you saw Nick June talk about this as well, and he has lots of brilliant explanations of really good ways to use this. Mine is going to be shorter and quicker and less brilliant, but it does allow us to do some prioritization because we have how much something differentiates our business at one axis, and we have the complexity of that thing in the other axis. And then we can place things like, say, we have authentication is quite complex if we try to build it from the bottom up, but everybody does it. It doesn't make my business different from your business that you're able to log in. We can do notifications. So again, not very differentiating, but maybe we're good at it, so we send them right at the right time, or we send it in the right channel so people don't get annoyed. Then we can maybe be better than the competitor that just spams away. But maybe not that differentiating, and maybe not as complex as authentication. And we have that loyalty program. Okay, it's also something that many companies do, so it's not setting us vastly apart, but maybe a bit more, especially if we do it well. And then we might come up with this very special personal shopper, AI, machine learning, whatever buzzwords put together, and that might also differentiate us and might be sort of complex. So we can group these things into what the core is, what's supporting the core, and what's generic that we should probably just sort of either download or buy. And well, it doesn't have to only guide whether we download or buy. You can also guide where we put in the testing effort. And I think it all sort of works together because it does. I had the drawing with the bubbles, the different color bubbles, and it was more broken down than the green one. And well, that was probably the core, and that's where we want to put in the effort, and that's where we also probably want to put in the testing effort. So these things actually line up quite nicely. Then this is not a static view, really. What tends to happen is that everything moves back towards zero differentiation because markets move forward, so everything gets commoditized over time. Your competitors start copying your things, and you copy your competitor, and then it becomes more and more like. So if you actually want to keep differentiating, you can't leave something alone. You have to actually work with it, and that means that you can, with the wide arrows, you can concentrate something and move it. So it's not just static. It's also a question of, okay, we might be okay with notifications slipping completely into just being generic, because at that point we can just retire our own service and buy it from a third party, and that's probably cheaper than maintaining it ourselves. But the loyalty program, we have lots of good ideas, so we actually want to move that the other way. We want to be better than our competitors. We don't want to just copy them, we want to get ahead with that one. So that's also an input. Okay, so that means that loyalty program is probably a good place to get a really good service level test coverage, so we can experiment, we can move fast, and we can really be continuous about it. So back to this one, that the more broken down areas, that suits really well with the types of tests that I've talked about. And luckily, that also tends to go hand in hand with the areas that we as a business want to work with and want to do experimentation with and want to work quickly with. So that's pretty good. That actually works together. So last real slide, the too long, didn't read slide. Focus on service level tests. That's the thing you should remember. That's the gist of it. Focus on service level tests. And service level tests are things that functionally test one complete service with the other microservices stopped out. It tests all the important scenarios, both positive and negative, and it focuses on testing the business capability that this service has. Then we have the other kind of service level tests, the contract tests, that you also want, so you also get the complexity of what's going on between the services. And we're actually a bit early, so I guess we have time for questions if there are some. I can't really see anything, so you just shout if we have some questions. There's a hand over there. Sorry. Didn't I write tests that were dependent on each other? So the contract tests were dependent on the other ones? Yeah, because you didn't use the inline data from the previous. Yes, that's true. That's a nice point. That the two styles of service level tests here are dependent on each other. That the functional one feeds the test scenarios into the second one, and usually we want to have independent tests. That's true. I handle this by grouping them. So we have the behavioral ones that are run with my loyalty program, and then at a second stage in my CI, I would take the output of that and run the contract ones. And yes, that's a dependency. And it's a trade-off that I'm willing to make to get the coverage of both the behavior and the contracts. But you have control on it, so it wouldn't be flaky. No, it shouldn't be flaky because there's a sequence to how we run it in CI. Yeah. Yeah. Yes. So the question over here is that I talk about testing the behavior, and I think I even mentioned not to mock too much. And you're saying in the Growing Object-Oriented Software book, they actually do use a lot of mocks. So somebody's done their homework very well. And you're right. And I don't really agree with that part of the book. I very much agree with the driving things from the outside in, but I think it can be done with a lot less mocking than what they do in the book. So I agree with you. That is a caveat, and maybe that's part of what's just happened in the past 10 years, that we've realized that we don't need as many mocks. Yeah, one more hand. Yeah, so the question is, what about side effects? If we run the whole service, we're doing something to its database and stuff like that, and that's persistent, so that's side effects. I guess that's the kind of thing we're talking about. Yes, that's nodding. And yes, that's true. The way I handle this is leaning on things like containers and bringing up my service in a container in my continuous integration environment. So for each run, it'll be a new one. Then, I mean, there's a trade-off. Do you want to bring the container down and back up again between each test? Do you want to wipe the database between every test? Or are you able to run the whole test suite with the whole test? That's less pure, but usually faster. I sort of tend towards that in practice. That actually good enough. That on each run of the test suite, you get a fresh start. But of course, that's not as pure. So I get that can be a caveat as well. So yeah, it depends. Kind of answer. Is that okay? Yeah. We do have time still. There, right there.
A lot of the contracts that mostly read data, and the post is easy, but you want to return the specific data. And when you call the real version, you won't get the same as the one you have to mock.
Yes, good point. Yeah, so you're saying this was a write style of contract that I was looking at. So what about read style, where you mostly query data, get something back from a get endpoint instead of posting something to a post endpoint? Well, I think in a sense those are almost easier. Maybe not as automated, but they're more stable in the sense that now the mock is very much in charge of what the answer is. So it's a question of checking the answer that the mock has against the real thing as well, and doing it when rolling your own and not writing too much of a framework like we just did here. I think you'll have a bit of manual. You'll have to sort of keep on top of keeping that up to date, and that's the downside of doing it yourself. I think that's actually one of the things that Pact will do better for you than what I'm sort of driving towards here. So that could be one of the reasons for using that tool, which is a good tool. I don't want to leave you with anything else on that. Yeah.
Servicelevel test, we actually have other microservices, but in contract test, we actually call one of the other microservices for assertion. So doesn't it correct this rule that we stop and it should be an
Yeah, so, okay, the question is that with the contract test, we actually go out and call another service. So is the isolation level really a service here? And I see your argument that it's not. So we could put in a third level or level more and say that we have the service of its own, and then we have the arrows between them, the contracts that we're testing, and see that as a different level. And I think that supports a little bit the other question, which was, aren't these dependent? And yes, so I would run them actually sequentially, doing the top level ones in one step and the contract ones in another step in CI, and that does sort of depend that you could definitely see it as different levels as well. Last question, I think, if we have one. There's one up there. Yeah, so the question is that with the contract test, we can also express the contracts more formally with the Open API. We could do it with proto files for gRPC. There's different ways of GraphQL, so on. We can specify contracts in different kinds of ways, and then we can base the mock on that. I think all of those are also good ideas to base your mock on. I don't think it covers everything that you actually have in the contract, because the contract defines the shape of the messages that you can send back and forth, but there's also assumptions about when I send this message, I get this back, and those I think we still need to verify at a slightly more detailed level. But if we have formal contracts, I think you can get part of the way there, and then you have less left to do with the contract test. So yes, that's also good to be formal about your contracts. So I hope that kind of answers that. I think that's the time we had. There were still some hands. You can just grab me afterwards and we can have a conversation. So thank you for listening.